This is RD Sharma solution, class 12th, differentiation exercise 11.3, chapter 11. Differentiate tan inverse x divided by under root a square minus x square. Please remember, x has to be between negative a and a. So, whenever we talk about tan inverse, you need, in order to cancel, because you cannot directly differentiate it. If you want to, you can, because we know about that. But why not to cancel these two out? So we need a tan. So whenever we have a squared minus x squared kind of thing, we always take x is equal to, because we need something so that we get some formula of trigonometry. So x is equal to a sine theta will put. So what do we get? Tan inverse x is a sine theta, and then we have this under root a square minus, in place of x again, a square sine square theta. So we have tan inverse is already there, so we want this to be something with tan. A sine theta, a square multiplied by 1 minus sine square theta inside, if you take a square, and that a square will come out, so it will be a under root 1 minus s square. So a sine theta, you have a 1 minus sine square theta is cos square theta, and when we have a root, so cos square will cancel, so you get a cos theta. A gets cancelled, sine theta by cos theta is tan theta. So we wanted that, we got it. Tan and tan inverse you can cancel now. But since the boundary is also given, x has to be between negative and a. So you have by yourself thought that, oh, x equals to a sine theta I will use. So is that correct? Is that correct? So you have to emphasize and you have to show the examiner that this x equals to a sine theta will not point to any error. That means it is between the desired limit when we can have tan inverse and tan gets cancelled in that particular region. So sine theta will become x by a here. Divide both sides by a, what I am doing right now. Minus 1 here, x by a here. A and a gets cancelled. So x by a is between negative 1 and 1. So sine theta is, this x by a is, between that is x by a was what? Sine theta. So now you can take sine inverse. Or you can just say that, okay, we know that the angle minus 1, when we have minus 1 and 1, what will be the value of that angle? So sine inverse 1 and sine inverse negative 1. So this get cancelled. You have a theta, sine inverse negative 1. So it is negative pi by 2 minus 90 degree. Sine inverse 1, which is pi by 2, which is positive, pi by 2 basically 90 degree. So we can just write pi by 2 here. Now theta between minus pi by 2 and pi by 2, that is, there is a point where we have pi by 2 and negative pi by 2. You can just take it in the denominator also, which is on the negative y-axis. So when we have between pi by 2 and minus pi by 2, you can cancel tan and tan inverse without even adding or subtracting anything from the theta. Otherwise, there can be some pi minus theta, there can be some pi plus theta, there can be pi by 2 minus theta, or whichever. Or a general solution kind 2 and pi plus or n pi, whatever we have already seen in the trigonometry. But here we are under the limits. So now you have to just differentiate theta. Theta is sine inverse x by a. Now let us differentiate this sine inverse x by a. And dy by dx of sine inverse x by a will be what? We know that it is 1 by under root 1 minus x square. Alright. So 1 by under root 1 minus x square. I will show you also if you just want to see the solution or see how you need to write. So 1 minus x square by a square, and then x by a, there is x by a, so you have to differentiate x by a. And then x by a will give you 1 by a. But what is the denominator? A square minus x square by a square. This under root a square goes up. It will be a only. So a by under root a squared minus x squared. Alright. And we have a x by a also. and that gives you, because you have to use the product rule, the chain rule. The differentiation of x by a, 1 by a is constant, so you don't have to worry about it. D by dx of x is 1. So a gets cancelled. You have finally 1 by under root a square minus x square. This is your final solution. Now sine inverse x by under root a x square plus a square. So you need what? You have x by something, and that we have to convert into some sign. Something with sign, so that we can cancel sine and sine inverse. Now we already know what is the relationship between sine and cos. Sine square theta is plus cos square theta is equal to 1. But when you have under root a square plus x square, what do we put? X equals to a tan theta. That we have discussed earlier also. So x is a tan theta that we are going to put. So we will first resolve this. We will not jump into the differentiation directly. We will try to resolve this x a tan theta. Let us see this. A tan theta, x is a tan theta, divided by under root x square plus a square. X square is a square tan square theta, plus this is a square. You have a tan theta. A square, if you take constant, it will come out, means outside it will be a, because a square you can take outside and it will come a. So I am taking it as a under root a square is a. 1 plus tan square theta is sec square theta. Because it is in root, so only sec theta will come out. Finally, you got a tan theta divided by a sec theta. A gets cancelled. Sin theta is sin by cos. Sec is 1 by cos. Cos gets cancelled. You just get sin theta. That's what we wanted. So sin inverse. Now finally, what we are going to do, sin inverse sin theta. Sin you will just you can nullify, and theta is tan inverse x by, that we will differentiate. But is there any condition? No. There is no condition being given. So you can directly go ahead. X equals to a tan theta. So from here, we will try to find out what is theta, because this x equals to a tan theta is being put by us, not by the examiner or whichever. We have put it. So we have to be very sure about that. So this is theta is tan inverse x by a. So essentially we have to differentiate this tan inverse x by a. Y equals tan inverse x by a. So dy by dx is 1 by 1 plus x square, 1 by 1 plus the content. So tan inverse inside this, it is x by a. So 1 by 1 plus x square by a square, you get a square, x square, a square goes up. So we have a square by a square plus x square. And since we have x by a also, we have to differentiate x by a also. So when you differentiate, 1 by a will come out, d by dx of x is 1. So you get 1 by a gets cancelled. You have a by a square plus x square. That is your final answer. A by a square plus x square. This is dy by dx. Now this, there is one more question coming like this. So for that, there is just one thing you need to know or recall. You might be knowing it, might not be recalling it. Remember, because some trigonometry we have learned long back, and to recall that it may be difficult. 2 cos square theta minus 1 is cos 2 theta. Cos 2 theta is also 1 minus 2 sin square theta. Please remember. So we'll replace x by cos theta here, so that we can get 2 cos square theta minus 1. So 2 cos square theta, x is cos theta. So 2 cos square theta minus 1. And 2 cos square theta minus 1, I just told you it is cos 2 theta. So cos 2 theta it will be. Or cos 2x, whichever you call. So sin inverse cos 2x it is basically. And we have put a theta, so we have introduced a theta also. But theta is what we have introduced, not anybody else. So this is cos, and sin can always be converted. Sin pi by 2 minus theta is this. Sin inverse gets cancelled. You get pi by 2 minus 2 theta. So you have theta equals cos inverse x. So pi by 2 minus twice of theta is cos inverse x. This is your y. Y is pi by 2 minus 2 cos inverse x. But you have a boundary also. X is between 0 and 1. So pi by 2 minus 2 theta, whole of this you have to check between 0 and 1. because that is what question is saying. Theta is being introduced by us. It is our responsibility to show that theta is also between this boundary. So cos theta is what? X. So this is cos theta between 0 and 1. And when you take cos inverse, that is cos inverse all the side or all the points, you get cos inverse 0. Cos inverse 0 is what? What is the value of cos? You get 0. So cos pi by 2 you get. And cos this 1, it is going to be cos 0 is 1, cos pi by 2. Cos 0 is 1, so cos pi by 2 is 0. So you can just replace this by 0 and pi by 2. And this cos and cos inverse of course gets cancelled. But we need pi by 2 minus 2 theta. This is just theta, okay? Cos inverse gets cancelled. So you just have a theta. Now you have to have pi by 2 minus theta, so you need to have a 2 theta first. So you have 2 theta, multiply everything by 2, so pi, 2 theta and 0. Now you have negative, so multiply all the elements by negative. The angle changes, means the inequality changes, multiplied by minus. And then we have to add pi by 2, so that we get pi by 2 minus 2 theta. Add pi by 2 minus pi is what? Negative pi by 2. It's pi minus pi by 2 is pi by 2, because it is pi by 2 minus pi, it is negative pi by 2. So let us write negative pi by 2 here. Inside this, we already have pi by 2 minus 2 theta. And here 0 plus pi by 2, so it is pi by 2 only. Now, we have already seen in one of the question that when you change sign and means try to cancel this sign and sign inverse, there are possibilities with their inverse trigonometric background knowledge we have that we cannot do it directly. So minus pi by 2 and pi by 2, you can do it in between negative pi by 2 and pi by 2. So we have got negative pi by 2 and pi by 2. This is the interval. Okay, this is already the interval. So we don't have to worry. We just have to differentiate it, dy by dx. So pi by 2 minus 2 cos inverse x, we are going to differentiate. Pi by 2 is a constant, so it will be 0. Minus 2 cos inverse x is 1 by under root 1 minus x square, negative. So negative positive, twice by under root 1 minus x square. This is dy by dx. Now we have to differentiate sin inverse 1 minus 2x square. I just indicated you, if you put x as sin theta, 1 minus 2 sin square theta is equal to cos 2 theta. Other things remain the same. The previous question and this question are exactly almost similar. Just have to put x as sin theta, so that you get 1 minus 2x square as 1 minus 2 sin square theta, that is equivalent to, or that is equal to cos 2 theta. I hope you got the idea. This is cos 2 theta. You'll do it by yourself. Differentiate cos inverse x by under root x square plus a square. So x square plus a square, wherever it is, we have seen so many questions. We have already placed x as a tan theta and a cot theta, like that. Here we are going to, because we need cos inverse, so something so that we can cancel it out with cos inverse. So x equals to a cot theta, we are putting x is a cot theta. Here x square plus a square, so x square will be a square cot square theta. A square will remain like that, so it will be a cot theta. And you have a square, you can take common. It's just a. It comes out under root 1 plus cot square theta, which is nothing but cosec square theta, and since it is under root, so it will be cosec theta. Under root of cosec square theta will be cosec theta. Alright. So we have a cosec theta. Cot is cos by sine. Cosec is 1 by sine. So this sine gets cancelled and cos it will be. So why we have done all this? Just because we know that it gets cancelled. And since there is no boundary being given, cos inverse, cos and theta, so you can just cancel this cos inverse. So you have to differentiate only the theta. So when we have placed x equals a cot theta is going to be x by a, and theta is going to be cot inverse x by a. So now put this theta as cot inverse x by a, just put it here, cot inverse x by a, dy by dx of cot inverse x by a is negative by 1 by under root 1 plus this thing x by a whole square. So differentiation of x by a also, it is going to be 1 by a. So what do you get? A square plus x square, and a square will be in the denominator. I am taking it into the numerator. Negative a square, a gets cancelled. You have 1 by negative 1 by negative a by under root a square, a square plus x square only. Okay, this question and the next question, they are almost similar. So please, pay more attention here. There is the boundary being given, that is the where x should belong, negative 3 pi by 4 and pi by 4. Alright. So this sin x plus cos x by root 2, what do we do? 1 by root 2 is sin and cos. The basic point here is this 1 by root 2 sine and cos 45 degree will be, see, this is 1 by root 2, 1 by root 2 if you take with sine x and cos x, because it is in the denominator, you can take separately. This is 1 by root 2 sine x, and then we have cos x 1 by root 2. Cos x 1 by root 2. Okay. Why we have written this? Because sine pi by 4 and cos pi by 4 both are 1 by root 2. Sine 45 degree or cos 45 degree, they both are 1 by root 2. And since the question is already giving us 1 by root 2, so we can replace it that, so that we can get a formula out of it. And that formula should contain sine, so that we can cancel it with sine inverse. The whole idea is that sin x cos pi by 4 plus cos x 1 by root 2 is sin pi by 4, and sin a cos b plus cos s sin b. What it will be? Sin a plus b. So sin x plus pi by 4. So this is a, this is b, and all these formula are very important, They can be applied anywhere. You never know. So need to mug up all these. Sin inverse sin x plus pi by 4, and x plus pi by 4 again, since there is a limit being given, minus 3 by 4 and pi by 4, so you have to show the examiner that when I am cancelling sin and sin inverse in this case, I am taking care of the limits. So negative 3 pi by 4 and pi by 4, x is between these two. So x plus pi by 4, so just add pi by 4, both here also pi by 4, here also pi by 4. So pi by 4 minus this pi by 4 plus pi by 4 is what? Pi by 2. So this is pi by 2. This is x plus pi by 4, and pi by 4 minus 3 by pi by 4 is minus 2 pi by 4, and that brings down to minus pi by 2. Now between minus pi by 2 and pi by 2, you can always cancel sine and sine inverse, that we already seen in the previous questions. So direct differentiation you have to do now. Sine and sine inverse cancel. You just have to differentiate x plus pi by 4, and this is x will be equal to, this pi by 4 is 0, x is going to be 1. Differentiation of x is 1. Same thing here, exactly same thing. So you have to write cos inverse, and this is sin cos x and sin x, and whichever formula you know, but that formula should be cos something, because ultimately you have to cancel this cos inverse and cos. So whatever you do, first thing is this, that's 1 by root 2, you have to write something. So what you have to write here? You have to write cos pi by 4, because remember cos pi by 4, sin pi by 4, both are 1 by root 2. So we have cos x, cos pi by 4, and then we have sin x and sin pi by 4. So cos x, cos pi by 4, sin x, sin pi by 4. Alright, and this formula, that is cos a cos b plus sin a sin b, is cos a minus b, and it's up to you how do you pick up Whether you want cos x first or cos pi first, it's up to you. But the final version, final output of this, what we have done is cos a minus b. A I have taken as pi by 4. So cos pi by 4 minus 1. You already have a cos inverse outside. Cos inverse you can cancel. You have pi by 4 minus x. You have to differentiate. Pi by 4 will be 0. And negative x is 1 only. So negative 1 will come. The differentiation is not that issue. It will be negative 1. And that is your answer also. But you have to show examiner that have you done it correctly? X is between negative pi by 4 and pi by 4. So this negative pi by 4 x is between these two. And you have to have pi by 4 minus x. Pi by 4 minus x, then only you can cancel cos and cos inverse if it is between 0 and pi. So let us see. Multiply negative all the way. And whenever you multiply negative, the inequality sign changes. It's going to be negative x. Here you have negative pi by 4. Here you have pi by 4 plus pi by 4. Now you add just pi by 4 everywhere. Just add pi by 4. Here also you add pi by 4. So you have pi by 4 minus x. And this is 0. This is pi by 2. So there is no problem because sine and cos inverse you can always cancel if it is between 0 and pi. But you are already between 0 and pi by 2. So doesn't matter. Alright, you got the point. 0 to pi you always cancel cos and cos inverse, but you are between 0 and pi by 2. So you are good to go. And I already told you what is the differentiation. It is negative 1. Alright. So final answer is negative 1. But this boundary has to be taken care. Please remember, I always say that. This question will take in the next discussion. Till then, thank you so much.